Lateral inversion is an interesting property shown by the images formed by the plane mirror. This is one of the property that is shown by the images formed by the plane mirror. This is the time to discuss about the remaining properties of the images formed by the plane mirror. Along with, as we have already discussed, that shadows are always black in color. Now, by doing the comparison between the images formed by the plane mirror and shadows formed by an object, we are going to discuss about the remaining characteristics of the image formed by the plane mirror and the shadow formed by an object. If you are standing before a plane mirror, you will find that the image formed by plane mirror of your is as far behind the mirror as you are standing in front of it. This is the first property given in the book. Second is the image form it is erect. आपका हेड ऊपर की तरफ, फुट नीचे की तरफ, that is erect and has the same size as you are. Third characteristic is the image cannot be obtained on the screen. If you are putting a paper on the mirror, can you draw your image there? No, you can't. So you can't obtain your image in the screen. This is because it is virtual image. And the last characteristic, the image formed is laterally inverted with respect of you. These are four characteristics of the images formed by the plane mirror. Now we are going to discuss about the difference between an image formed by the plane mirror and a shadow formed by an object. Text will be read later. First of all, I am going to explain you. If you are standing before a mirror and your friend is watching you in the image of your in the plane mirror, will he able to identify you? Yes, he will, because image of your gives complete information about you to the observer. But if you are forming a shadow, can your friend identify whether it is you or somebody else? Not. So first characteristic is images formed by the plane mirror gives correct information about the object. But shadows do not necessarily identify the object and also do not give the complete information about the object. सेकेंड, इमेज इज एज कलरफुल एज द ऑब्जेक्ट इज. आपने जैसी ड्रेस पहनी है मिरर में आपकी इमेज में भी वैसी ही दिखाई देगी. बट क्या शेडो में ऐसा होता है? नो, शेडोज आर ऑलवेज ब्लैक इन कलर. Images can be obtained on the screen. Images cannot be obtained on the screen, while the shadows can be obtained on the screen. Images show lateral inversion, but such a phenomenon is not observed in case of shadows. And now the last one, image of an object in a plane mirror has a fixed size irrespective of its distance from the mirror, while the size of the shadow of a given object depends upon the relative position of the source of light and the opaque object. This is all about the difference between the two, image and shadow of an object. Now I am going to take you towards a surprise today. Would you like to make your own camera? Better option is to make pinhole camera. What is pinhole camera? A pinhole camera is a simple application of the property of light, ordinary light moving always in a straight line. So, pinhole camera is a device which is based on the property of that light always travels in a rectilinear path. Now, you can see if we are making pinhole camera and seeing an object through it. The image formed will be inverted and diminished. Invert मतलब उल्टी, diminished मतलब छोटी. Would you like to discuss that how can we make a pinhole camera? So for doing that, let's discuss activity number 5 there. We are asked to take two cylindrical cardboard tubes. What is the better option with us? We can take the cardboard tubes, cylindrical cardboard tubes that are left over after using the aluminium roll of aluminium foil. मम्मी जिसमें रोटी रैप करके देती है ना, वो जब खाली हो जाता है तो उसके अंदर से आपको ये मिल जाएंगी. Put the tube having the smaller diameter into the tube having the larger diameter. Now you will get the two ends of that arrangement. Cover one of the side with the aluminium foil and make a hole with the help of pin. Do you know that's why this camera got its name, pinhole camera. And on the other side you will tie a butter paper with the help of rubber band. On both the side you can use rubber band to wrap, to cover the mouth of these tubes with aluminium foil and butter paper. Now you can put a lighted candle before that hole, and what you will observe? You will observe the inverted and diminished image of that lighted candle. This is how we can conclude that a pinhole camera always make inverted and diminished images. Now I'm going to read text given in activity number 5. Take two cylindrical cardboard tubes, one having a smaller diameter than the other. Cover one of the open side of the smaller tube with the butter paper. Use an aluminium foil over one of the opening of the larger tube so as to completely cover it. Use rubber bands, etc. if needed to hold the butter paper and aluminium foil in their respective places. With the help of a pin or a sharp needle, make a clean hole in the center of the aluminium foil. Slide the smaller tube into the larger one and keep the foil and the butter paper slides outward. The pinhole camera is now ready for use. Put the camera on a suitable base. Just hold it in a hand, or you can hold it in a hand so that the hole in the aluminium foil is facing some well illuminated distant object. Slide the smaller tube back and forth until you see a clear image of the object on the screen, that is butter paper. How does a simple hole allow us to see an image of the object? Why is the image upward down? It is easy to realize that this is so because light propagates in straight line path. This results in the formation of an inverted and diminished image of the object on the screen. So dear student, don't stop yourself. Search some cylindrical tubes and also try to make your own pinhole camera. This is all from today. Thank you. Have a nice day.